Section 517.63 addresses electrical requirements and anesthetizing locations, specifically concerning receptacles and grounding. The key point is that 517.63 does not prohibit the use of receptacles supplied from a grounded service in an other than hazardous anesthetizing location. However, it does impose a restriction on the type of receptacles that are permitted. The section's last sentence is crucial for understanding this restriction. It states that receptacles provided for the connection of portable equipment in anesthetizing locations shall not be of the isolated ground type. This prohibition targets isolated ground receptacles, often abbreviated as IGR. An isolated ground receptacle is a specific type of electrical receptacle designed with a grounding terminal that is intentionally isolated from the equipment grounding conductor of the electrical system. The purpose of this isolation is to minimize electrical noise and interference that can be transmitted through the grounding system, potentially affecting sensitive electronic equipment. In essence, IGR are designed to provide a cleaner, more stable ground reference for connected equipment. The grounding terminal of a standard receptacle is directly connected to the equipment grounding conductor, providing a direct path for fault current to flow back to the source. This is the conventional grounding method used in most electrical installations. In contrast, an IGR grounding terminal is isolated from the equipment grounding conductor within the receptacle itself. The isolated grounding conductor is then run separately back to the main grounding point, typically the service entrance, without making contact with any other grounding conductors along the way. This dedicated path helps to prevent noise and interference from other equipment from contaminating the ground reference for the sensitive equipment connected to the IGR. The prohibition of IGR in anesthetizing locations stems from concerns about maintaining a reliable and robust grounding system for patient safety. In healthcare environments, especially anesthetizing locations, the potential for electrical leakage currents to cause harm to patients is a significant concern. A properly grounded electrical system is essential for minimizing this risk by providing a low impedance path for fault currents to flow, allowing protective devices like circuit breakers to quickly interrupt the circuit in the event of a fault. Isolated ground receptacles, while beneficial for reducing electrical noise, can potentially compromise the integrity of the grounding system if not installed and maintained correctly. The isolation of the grounding terminal can create a higher impedance path for fault currents, which could delay the operation of protective devices and increase the risk of electrical shock. The code stipulates that standard receptacles, which have their grounding terminal connected to the equipment grounding conductor, are permitted in anesthetizing locations. These standard receptacles provide a direct and reliable grounding path, ensuring that fault currents can be quickly and safely cleared. The use of the word normal in the last sentence of 517.63 refers to the typical or conventional grounding method used in other locations. In most general-purpose electrical installations, standard grounded receptacles are the norm. However, in anesthetizing locations, the use of IGR is specifically prohibited due to the critical need for a robust and reliable grounding system for patient safety. Therefore, the grounding method in these locations deviates from the normal practice of using IGR for sensitive equipment. In summary, 517.63 allows for the use of grounded receptacles connected to a grounded service in anesthetizing locations, but it explicitly prohibits the use of isolated ground receptacles. This requirement ensures a consistent and reliable grounding system to minimize the risk of electrical hazards in these critical healthcare environments. The rationale behind this requirement centers on patient safety and the need for a robust and dependable grounding system in anesthetizing locations. The electrical system in an anesthetizing location must be designed and maintained to minimize the risk of electrical shock or other electrical hazards to patients and medical personnel. The grounding system plays a crucial role in achieving this goal by providing a low impedance path for fault currents, ensuring that protective devices operate quickly and effectively. The prohibition of isolated ground receptacles is intended to prevent any potential compromise to the integrity of the grounding system. While IGR can offer benefits in terms of reducing electrical noise, their isolation of the grounding terminal can also introduce a higher impedance path for fault currents. This could delay the operation of circuit breakers or other protective devices, increasing the risk of electrical shock. By requiring the use of standard grounded receptacles, 517.63 ensures that the grounding system provides a direct and reliable path for fault currents, minimizing the risk of electrical hazard. The term normal in this context refers to the typical grounding practices used in general-purpose electrical installations. In most commercial and residential settings, standard grounded receptacles are the norm, and isolated ground receptacles are only used in specific applications where sensitive electronic equipment requires a cleaner ground reference. However, in anesthetizing locations, the need for a robust and reliable grounding system overrides the potential benefits of IGR, making the grounding method in these locations different from the normal practice. It is important to note that 517.63 does not prohibit the use of other types of receptacles or electrical equipment in anesthetizing locations, as long as they meet the applicable requirements of the National Electrical Code and other relevant standards. For example, ground fault circuit interrupters, or GFCIs, are often required in wet locations or other areas where there is a higher risk of electrical shock. GFCIs are designed to detect small leakage currents and quickly interrupt the circuit, providing an additional layer of protection against electrical hazards. Furthermore, the electrical system in an anesthetizing location must be designed and installed in accordance with the requirements of Article 517 of the National Electrical Code, which covers healthcare facilities. Article 517 includes specific requirements for wiring methods, grounding, and other electrical safety measures in healthcare settings. These requirements are intended to minimize the risk of electrical hazards to patients and medical personnel. In addition to the requirements of the National Electrical Code, healthcare facilities must also comply with other relevant standards and regulations, such as those established by the Joint Commission and other accrediting organizations. These standards may include additional requirements for electrical safety and equipment maintenance. The proper installation and maintenance of the electrical system in an anesthetizing location are essential for ensuring patient safety and minimizing the risk of electrical hazards. Healthcare facilities should have a comprehensive electrical safety program in place, including regular inspections, testing, and maintenance of electrical equipment. A program should also include training for medical personnel on electrical safety procedures and the proper use of electrical equipment. In conclusion, 517.63 allows for the use of grounded receptacles connected to a grounded service in anesthetizing locations, but it prohibits the use of isolated ground receptacles. This requirement is intended to ensure a consistent and reliable grounding system to minimize the risk of electrical hazards in these critical healthcare environments. The term normal refers to the typical grounding practices used in general-purpose electrical installations, which differ from the specific requirements for anesthetizing locations. Healthcare facilities must comply with all applicable requirements of the National Electrical Code and other relevant standards to ensure the safety of patients and medical personnel. The focus on a robust and reliable grounding system in anesthetizing locations is paramount due to the heightened sensitivity of patients undergoing medical procedures. Anesthetized patients are often more vulnerable to electrical shock or other electrical hazards, making it essential to minimize any potential risks. The grounding system is the primary means of protecting patients and medical personnel from electrical hazards by providing a low impedance path for fault currents. This allows protective devices to quickly interrupt the circuit in the event of a fault, preventing electrical shock or other injuries. The prohibition of isolated ground receptacles is a key element of ensuring a robust and reliable grounding system. While IGR can offer benefits in terms of reducing electrical noise, their isolation of the grounding terminal can also compromise the integrity of the grounding system. By requiring the use of standard grounded receptacles, 517.63 ensures that the grounding system provides a direct and dependable path for fault currents, minimizing the risk of electrical hazards. The normal grounding practices referred to in 517.63 are those typically used in general-purpose electrical installations. In these settings, standard grounded receptacles are the norm, and isolated ground receptacles are only used in specific applications where sensitive electronic equipment requires a cleaner ground reference. However, in anesthetizing locations, the need for a robust and reliable grounding system overrides the potential benefits of IGR, making the grounding method in these locations different from the normal practice. The electrical system in an anesthetizing location must also be designed and installed to minimize the risk of electromagnetic interference, or EMI. EMI can disrupt the operation of sensitive medical equipment and potentially compromise patient safety. The grounding system plays a crucial role in minimizing EMI by providing a low impedance path for unwanted electrical noise to dissipate. In addition to the grounding system, other measures can be taken to minimize EMI, such as using shielded cables, filtering electrical power, and properly grounding equipment. Healthcare facilities should have a comprehensive EMI management plan in place to ensure that sensitive medical equipment operates reliably and without interference. Furthermore, the electrical system in an anesthetizing location must be regularly inspected and maintained to ensure that it is operating safely and effectively. Regular inspections should include visual inspections of wiring, connections, and equipment, as well as electrical testing to verify the integrity of the grounding system and the proper operation of protective devices. Any deficiencies or problems identified during inspection should be promptly corrected to prevent electrical hazards. The maintenance program should also include regular cleaning and lubrication of electrical equipment, as well as replacement of worn or damaged components. A well-maintained electrical system is essential for ensuring the safety of patients and medical personnel in anesthetizing locations. In addition to the technical requirements of the National Electrical Code and other standards, healthcare facilities should also provide training to medical personnel on electrical safety procedures and the proper use of electrical equipment. Training should include information on the hazards of electricity, the proper use of electrical equipment, and the procedures to follow in the event of an electrical emergency. Medical personnel should also be trained to recognize and report any potential electrical hazards. A well-trained staff is essential for ensuring the safe use of electricity in healthcare facilities. In summary, 517.63 permits the use of grounded receptacles connected to a grounded service in anesthetizing locations but prohibits the use of isolated ground receptacles. This requirement is intended to ensure a consistent and reliable grounding system to minimize the risk of electrical hazards in these critical healthcare environments. The term normal refers to the typical grounding practices used in general-purpose electrical installations, which differ from the specific requirements for anesthetizing locations. Healthcare facilities must comply with all applicable requirements of the National Electrical Code and other relevant standards to ensure the safety of patients and medical personnel. The emphasis on patient safety and a dependable grounding system stems from the unique vulnerabilities of patients undergoing anesthesia and the critical nature of medical procedures performed in these locations. The electrical system must be designed, installed, and maintained to the highest standards to minimize any potential risks. The grounding system serves as the primary defense against electrical hazards, and the prohibition of IGR is a key component of ensuring its effectiveness. The normal grounding practices referenced in 517.63 represent the typical approach in general-purpose electrical installations. However, the specific requirements for anesthetizing locations reflect the heightened sensitivity and critical nature of these environments. The electrical system must be designed to minimize the risk of electrical shock, electromagnetic interference, and other potential hazards. In addition to the technical requirements of the National Electrical Code and other standards, healthcare facilities should also implement comprehensive electrical safety programs that include regular inspections, testing, maintenance, and training. These programs should be tailored to the specific needs of the facility and should be continuously reviewed and updated to ensure their effectiveness. A proactive approach to electrical safety is essential for protecting patients, medical personnel, and visitors in healthcare facilities. The electrical system in an anesthetizing location is more than just a collection of wires, receptacles, and equipment. It is a critical infrastructure that plays a vital role in ensuring the safe and effective delivery of medical care. By adhering to the requirements of the National Electrical Code and implementing robust electrical safety programs, healthcare facilities can create a safe and reliable environment for patients and medical personnel.